Hey everyone, it's Mrs. Slauson, and we are still in our Chapter 4 packet. Today we are going to be covering the substitution method as far as systems of equations goes. We looked at the graphing method in our last video. I'm on page 4 in our Chapter 4 packet, and I'm on the bottom half, and there's a total of 3 problems, and we're going to do 2 in the video, and then I'm going to save one of them for us as a class. So we're just going to go over these summary of steps. I did add one extra thing in here. So the first thing you want to do, and this is a time to use the substitution method, is when you look at your 2 equations, we want at least one of them, it says, to be in the form y equals, and it says mx plus b because we're just going to be working with linear equations here. But you want one of them to be in the form of y equals everything else, or it could be so x equals everything else. So maybe make that little note. It doesn't have to just be y equals. It could also be x equals. All right, so for instance, when I look at number 3, I've got one of the equation is y equals everything else. On number 4, they're both y equals everything else. But on number 5, it's x equals, and then everything else is on the other side. So all of these 3 are prepped and ready to go for our substitution method. So what you want to do is you want to find which equation you're going to use to substitute into the other equation. And the one that you want to substitute is one of these 2 up here. You want to substitute that one that's y equals everything or x equals everything. So for number 3, the y equals 6x minus 11, this is the one that I'm going to substitute in. So what I'm going to do is just circle this part, okay? And that's what this is saying. So now what I'm going to do is I'm actually going to substitute this equation into the other equation. So since this is y equals 6x minus 11, I can go to where this y is and replace it with 6x minus 11. You might want a calculator in case the numbers get too big, but we'll see what happens. So I have negative 2x, and then what's going to go in place, sorry, let me back up. I have negative 2x minus 3, but instead of y, I'm going to replace y with 6x minus 11, and I'm going to put that in parentheses when I do that. And then I still have the equals negative 7. Okay? So, again, you might want a calculator. I'll just have mine off to the side. We'll see how much math we can do. So what I need to do is start solving for x, which is what we did in our very first chapter this year. So the first thing I'm going to do is just distribute. So I'll have the negative 2x. Subtracting 3 multiplied into the 6x is like negative or minus 18x. And subtracting 3 with the subtracting 11, that actually becomes like a positive, so plus 33 equals negative 7. That was our first step in solving, get rid of the parentheses. Then we would combine our like terms, so I'm just going to put these together. So if I have negative 2x and I take away 18x more, I'm down to negative 20x. And then from there, I need to solve and start getting x alone. So what I'm going to do first is take this 33 and move it over to join the negative 7. I'm going to do that by subtracting 33. And again, you can use a calculator. That's totally fine. Those would cancel out. On the left side, you still have the negative 20x. And on the right side, negative 7, take away negative 33 is a negative 40. You can use your calculator if you need to. And then the final step to get x alone is, since these 2 are being multiplied, I'll undo that by dividing by negative 20. And when we're done, we get x is 2, because negative 40 divided by negative 20 is 2. So now that we've solved x, we have a second variable to solve for, because in both equations there's an x and y. So what I'm going to do is take this value for x and put it into one of my 2 original equations. It really doesn't matter which one to do that with, but there is a better one in the substitution method. So going back to our steps, we did solve for the variable, we solved for x. But now we're going to solve for the other variable, and there's usually, again, a better equation to substitute into. And that equation is going to be the circled one. We're going to take this equation, y equals 6x minus 11. We're going to take the fact that we know x is 2. And now we're going to substitute 2 in for x. So it becomes y equals 6 times 2, I'll just put it in parentheses, minus 11. And then I can simplify this. I'll do my multiplying first. That's 12. And 12 take away 11. When I'm done, my answer is 1. So right now my answer is separated into x is 2 and y is 1. But we talked about in the last video and in our last class to make sure that you write it as an ordered pair. So the ordered pair version of the answer is 2, 1 because x is first and y is second. Okay, so if I did graph these two lines, this is the point where they would meet. So this problem has one solution. So let's take a look at the next one. So in this one, they're both y equals something, but we're not going to let that change it. So step one's been completed. We're going to pick which one we want to substitute. Again, since they're both y equals, it doesn't matter, but I'll just circle the top one. And what I'm going to do is substitute it into the other equation, and it's going to go right where the y is. So instead of y equaling negative x plus 3, it's going to be this in place for y. So 3x minus 1 equals the negative x plus 3. In this problem, we had parentheses to deal with, and then we combined like terms, and then from there we could start isolating x. In this one, there aren't parentheses. We are going to combine like terms, but it's with the idea that we want to move one x to the other side. So again, it's always better to move the smaller x. This is like a negative 1x to the other side. So what I'll do is add 1x. And on the left side, now I have 4x take away 1 equals 3. And now to get x alone, I'll add my 1 over. Those cancel out. We get 4x equals 4. And then I'll divide to get x alone. And when we're done, we get x is 1. So now what I'm going to do is take my answer, and I always go back to the one that I circled. And I'm going to take this equation and the fact that I know that x is 1 and put it in for there. I'll multiply again. That's just 3. 3 take away 1. When I'm done, my answer is 2. So here I get my two answers. I have x is 1 and y is 2. Again, we always want to write them as the ordered pair, so 1, 2. And that's it. We're going to come back together and do number 5.